Okay, hello everyone. So my name is Jesse Pham and welcome to the Materials Engineering Questions and Answers session. We will start off with some brief housekeeping items followed by our questions and answers session. So when you have a question, please use the Q&A button along the bottom to submit questions, and we will try to answer them in the order they were posted. There's also a chat room for you to make comments or chats with your peers. As a reminder, please use appropriate language while chatting or commenting. This Q&A session is designed to help both students and parents learn more about our program. So this session will last 45 minutes, and then we will encourage you to explore other sessions that may be of your interest. There are multiple programs and majors offering Q&A sessions today, and you can enter any session you want. In fact, we encourage you to explore all we have to offer. Without further delay, I would like to turn it over to our presenters. So go ahead and please introduce yourselves as we wait for any questions our attendees may have.
This is Asgar Kadesh. I am a faculty at Materials Engineering program, and we are under the Chemical and Materials Engineering department. I teach foundational level introduction classes. I also teach upper level mechanics materials classes. Some of these include also additive manufacturing, 3D printing. My research, I also do research at San Jose State. My research is on additive manufacturing and mechanical reliability, some ceramics processing, and computational investigation of microstructure property relationships. So overall, our goal is to, or my group's goal is to make materials much more stronger, lighter, more sustainable, and usable for humanity. And I have Anthony and Mina here. Mina, can you introduce yourself?
Yes. So hello, everyone. My name is Mina Tabakolzadeh. I'm a rising senior here at San Jose State, and my major is materials engineering with a minor in physics. I have experience in research in Dr. Kalish's lab, as well as some experience with a physics professor. And I've taken almost all the upper division courses. So if you have questions, I can definitely try to answer those. Anthony, want to?
Yep, I'll take over on that one. Hi, everyone. My name is Anthony Cheresa. I'm almost an exiting senior, so hopefully I can give you perspective on either course curriculum that you guys might have. I also research with Dr. Kellis on additive manufacturing, but I've been through freshman to senior year as material engineer. Again, I just want to make sure that I can help any questions that either incoming transfer students or freshmen that may have on the curriculum. Thank you.
And Anthony, can you briefly talk about your experience with NASA too, quickly?
Yes. Being at San Jose State, you do have the opportunity of having companies around. So as Dr. Kelly said, since fall 2019, I've been intern at NASA Ames, where I've done material characterization and material development. And it's kind of cool to work on, thermal protection systems such as the tiles that can go on entry vehicles. But also they're looking for people that can think and look at material development of things that aren't even known yet. So for one example for me is 3D printing of a blade of paste. So as you come up with an entry material, if you can 3D print that is one of the student projects that I'm working on right now.
All right, we have, I guess, participants here. We have about like 10. Is there any question? You guys can use the chat box or just directly ask anything.
I guess we can talk about some of the courses that we take as material engineers. Let me look at that. such as, metals and alloys, ceramics, polymers. And we also take some thermodynamics and solid state chemistry. And we also take some material selection and process design. And I don't know, Professor, you want to talk a little bit more about about the research opportunities that you provide at San Jose State?
You can talk about those and the other classes you like.
Okay. Let's see. I think. Okay.
Or Minat, what is your favorite class? So give us like the top 3 class that you like at San Jose State and you feel like it really helped you develop professionally. And meanwhile, Anthony, you can set up the classes and some research potential at SJSU and your basically nice smooth transition to industry or academia. Mina?
Okay, so I would say that my favorite class has been 141, which is crystallography and X-ray diffraction. And I just really enjoyed that class because I personally really love math and I love solid state physics and learning about the different space groups and different, point groups, and just like X-ray diffraction was really enjoyable for me. After that one, probably just Maddie 115, which is just general introduction, not introduction, just like overview of materials engineering. And that's because that class really teaches you about everything, and it's just like it gives you like where to start looking into and like independently learning about each topic. And then my third favorite class would have to be physics 52, which is optics. And in that class you learn about like lenses and this is introduction to thermodynamics and just but mostly optics and like how to work with lenses and stuff. So those were my favorite.
I think we have our first question from Robert Poe.
Yeah, you can, I guess you're in a good position to answer that, and I'll follow up, Anthony.
Great segue, Robert. So Robert asked, what are some of the other types of companies where internship opportunities are available? One thing great about San Jose State is it has a destination for it. So I've had friends that either have internships either at Apple or after they graduate their failure analysis at Google. So San Jose State really is the destination if you're looking for internship opportunities. For me, for example, I'm at NASA Ames as an intern, and I've, again, other friends that have gone there prior to me. But some other companies, we have a fuel cell company, either Bloom Energy, but again, you're really not limited to the type of industry that's in Silicon Valley. So if you look, or if you have connections with either professors, or we do have job career fairs where you have a minimum of 50 companies that go just on the technology and science side, and that could Lockheed Martin. Those are the bigger names, but that does not limit what type of industry you're looking into. So biomedical, Cepheid, there's just a range of opportunity and just being in San Jose. I hope that answered your question, Robert.
Yeah, if I may add, around San Jose State University, we have around 6,600 companies. About thousands of these companies are biomedical companies, and they also have to deal with materials. Remember, even the software companies these days have to deal with materials. And if you think about defense, aerospace, automotive, chemical industries, they all have to deal with materials from different points of view. Electronics industry, most of it is materials these days. And if you really want to push, and if you have a goal in terms of getting an internship in anywhere, that is totally achievable here. All right. And I don't know if I emailed your name to NASA, Anthony, but Anthony's group is actually as close collaboration with us. So I also get different types of internship requests as they know us, and then we direct it to basically students. You know, Anthony was working in my lab, so he's a natural choice. If you're also good in your classes, other professors will also forward those opportunities to you, but it is online, right? No, you know, competition is global, but you will have a much better advantage being here, right? NASA is not going to hire someone from like a, you know, far away state that easily, but for our case, they like it because you don't have to stay here just summer. You know, throughout the year, you can actually go to NASA and perform research and be involved. And this is true for almost all the other companies.
Yeah, especially for me, just even being at NASA, they were really helpful with my with the scheduling. So it's a 20-minute drive from campus to their facilities if the traffic is good. So 20 to 40, 20 to 30, we'll give them that. But yeah, as Professor Kellis was saying, a lot of the companies, it's material based. So what I liked about material engineering is, heck, yeah, you know, not only just the material aspect, but the versatility of that, either processing, manufacturing, quality analysis, quality assurance. These are some of the careers that you can go into if you have an interest in it. So it's a lot of versatility on that.
Okay, I see another question here from İsmet Gülleroğlu. Is materials engineering based on more chemistry or physics? Also, do you need to take calculus? Materials is actually the most interdisciplinary field in engineering. And generally, if you search for other universities, what you will see is materials, science and engineering as the department. So we are the only engineering department which has science in it mostly. And that actually shows our interaction, strong interaction with physics, chemistry, and math. And actually, it's also going to bio. Okay, so biology too, if you want to push it. But for normal undergraduate degrees and masters, if you deal with materials, yes, you have to pass through chemistry, physics, and calculus. And we cannot really say, you know, it's depending on chemistry or physics more, very hard. But we do have a strong solid state physics interaction, because physicists generally go to a, you know, atomic scale, maybe even lower electronic states. We are a little bit higher than them, right? So we have multiple atoms we deal with, but there is no other field who deals between those range of material structure. What I'm saying is, you know, above proton, electron, we are there, and then above, like, you know, something you can hold, like a steel bar, then mechanical engineering, other engineering disciplines get in, but something you hold bit and something electronic state in between, we are there. And all those things related to polymer will be more chemistry. The other things related to like optics or, you know, lasers or the semi-conducting materials, they will be more solid state physics. If you do additive manufacturing, it includes a lot of mechanics, structure, and if you're interested in the polymer viscosity type interactions there, that is more chemistry. So you can cover almost anywhere. And these days, I also started a new class, maybe 2021 spring, that will be related to materials informatics and data sciences. So we actually try to generate experimental or numerical data and use this data through machine learning and artificial intelligence, try to discover new materials and new science if possible. So it will be even more complicated, but this actually makes the discipline maybe a little bit challenging, but also makes it really a powerful way of switching to academia or industry, because you will have a large grasp of not only the basic science, but also the engineering. I don't know if I answered your question, or if you have a follow-up question, please let me know. All right, Anthony and Mina, do you guys want to add?
Oh, I'm sorry, cut out. Yeah, for Mina, I don't know if you want to talk a little bit more about the some of the clubs, the extracurricular activities that happen on campus. Instead of also along with classes and lab work, we're also exposed to material engineering in another way. And I think Mina is president of the Materials Advantage Club. I don't know if you want to say a few words on that, Mina.
Sure. So we have two clubs for materials engineering here at SJSU. One of them is SPE, which stands for Society of Plastics Engineers, and the other one is Material Advantage. And Material Advantage is a club made by 4 professional societies, and those societies are all ceramics and steel and metal industries. And therefore, if you join Material Advantage, you'll get to use the benefits of all 4 of those societies, meaning attend the conferences at a discounted price or join in our competitions. And we've been participating in 3 competitions in a long-term project. Those include a ceramic mug competition, which is for MS&T, and that's a conference. It'll be in Philadelphia, I believe. And another one is a metal blade competition that will be in for TMS, which is the Metals, Minerals, and Materials Society. And next year, that conference will be in Florida. And the other one is Materials Bowl, which is like a trivia competition. And this year, we participated in that in the TMS early February, I believe, in San Diego. We didn't win. It was our first time Colorado School of Mines won, but we did get really far, which was nice. But we have quite a few people in our teams. And our other project, which Dr. Kadesh is heavily involved in, is a virtual reality project. And for that one, we get to code materials engineering experiments in Unity and just make a virtual reality version of a lot of labs and experiments that are either expensive or difficult to do, and we'll have them for free available on our website so people can download them and just use them and help use them to as a learning aid. So yeah, those are our projects.
If I may add, I already put it into the chat box and an interview that I did with the SJSU VR Lab with variables, variable.com. And in there, you can actually see some of my projects and also a video that Ian did. Ian was an undergraduate student working with me on developing virtual reality modules to teach materials engineering. He's actually working at Lockheed Martin now. He was a good student, unfortunately, had to quickly switch to the company. But you can actually see some of the things that we have done there. And also we are trying to improve the virtual reality aspect and include teaching at least some parts of the classes using VR. And the beauty of the VR, from my point of view is, you can experience something that is almost impossible to experience in the real life. So you can actually see inside the material, what happens, right? What happens to a semiconductor when it is running, right? Or what happens to a camera when you take a picture, or what happens to a material when you try to pull and break it apart. We can visualize those much nicely, and you can actually have access to a virtual lab that might be actually impossible to get access, or it might be too expensive for us to get access at San Jose State. But you will definitely have the state-of-the-art systems and the state-of-the-art teaching opportunity, right? This is novel. No one else is actually doing this in the world to the level that we are doing. And I'm also expecting another grant to push that really forward and include it in many of the classes. So if you join our university, you will have these experiences that are also increasing. And one more thing that I would like to add, we also got a developed a new advanced manufacturing laboratory, which also includes a metal additive manufacturing system that uses lasers to make any kind of metal part. And then we do research on those. So that system is also unique. Not many universities have, at least in the capabilities of our university.
And I guess if I may add to the extracurriculars, one more thing, Society of Plastics Engineers, SPE, is our other club, and they are less project-based and more event-based, so they have different networking opportunities where they have a mentorship event where you'll be paired up with a professional, an experienced professional from the industry, and that person and you will decide how to communicate and when to communicate. But the goal of that activity is to just bond with someone who's had the same experiences that you'll be going through and get a lot of advice. So my mentor is a doctor named Bruce Prime, and he's a polymer scientist, and he's been working at Western Digital for 30 years. And through him, I was able to get an interview with Western Digital. Unfortunately, their labs shut down, so I'm not sure what's happening with that internship anymore. But just in general, it's a great opportunity. Joining SPE and MA are very good, I would say.
Yeah, I agree. I am actually the club advisor for both of those societies, and the SPE is specifically the mentoring event is really unique. You know, you get the experience and that you can't really buy, or if you want to buy, it's probably tens of thousands of dollars experience. This is given free by industry professionals because they really want to help the students that we have here, and they become an invaluable asset for students to really think about industry and what are some of the opportunities that are out there. They of course also give one of the some of the best tips possible about how to secure an internship, how to secure a job. I guess they also did some presentations and talks on how to negotiate your salary, right? Even for internships.
That was for MA, actually.
It's MA and SP, we call both of you at the same time, I guess. Yeah, both of these students clubs are pretty active, and they have been doing a great job recently.
Is everyone undergrad or transfer students that are online? Or do we have any incoming graduate students or anything like that on the, this is out to the web, this is, anyone in the Q&A?
Well, that's hard. Can they raise their hand if we ask? Like, raise your hand if you're on incoming
All right,
freshman.
ladies and gentlemen, Alexander, Aletron, Alondra, Camille, Daniel, Darren, Diane, Eric, Iwa, Robert, Sabrina, Lee, Justin, Jose, Isangche, Chu. Welcome all again. So let us know if you guys have any questions. I think I see a hand raising. You can ask the question. All right, so here is a question. What are the differences between materials engineering and electrical engineering? As in course, one has to take part for that. We do have probably one course, same with, or two courses, same with electrical engineering, EE 98, Introduction to Circuit, and 153, Electric Optic Magnetic Materials. And there might be a couple more that is overlapping with electrical engineering. But in electrical engineering, you will probably have much more math, signal processing, it's much more theoretical. In our case, we also have like photovoltaic processing lab. So you actually do solar cells, right, in our labs, and Mina and Anthony can talk about those. You can make actual fuel cells, I guess, during the ceramics lab. So we are more, more involved but there is also an overlap with, you know, a lot of fields. I don't know if you guys want to also talk about the answer for this question.
Yeah. As you go up in your core curriculum, you do have opportunities to look, as Professor Kellis, either photovoltaics or MEMS, which is micro electrical mechanical systems. But you also have EE classes, or with EE students, for circuit design, intro to circuit analysis, but also your prerequisites, intro to circuit analysis, you will have some overlap. There's a materials class. I forgot what the name was. Electrical materials and
electric, optic, magnetic materials.
That's what it was. But so there's an overlap, but and same with research. It's a lot of professors they do work with materials, and research is not, you're not set at one department. You can outreach. Mina is actually in the physics department. You're doing research in the physics department, Mina?
Yeah, and my research also includes a lot of electrical engineering. I do signal processing. What I specifically work on is a crystal of magnesium oxide, and the research I do is purely simulations, but we have physical data from Los Alamos laboratories in New Mexico, and what they did was they have a muon beam, which is a nuclear physics, and the muon is shut at the magnesium oxide crystal, and it decays into a muon antineutrino and a positron, and when the positron goes out of the crystal, we capture that signal and we try to look at signal versus time, I guess. And the application of that is in earthquake detections, because there's a theory that a couple of weeks before an earthquake, this happens, there's a huge flux of positrons coming out of the earth because there's magnesium oxide in the crust of the earth. So it does include a lot of physics, materials engineering, and electrical engineering.
All right, I have another question here. How well are the job prospects for materials engineering? It is growing, but you know, I don't want to say this, right? So for any of the questions, for any of the departments, and I also told these guys and my other students that you have to basically do your own homework, right? If you ask me, how is the job prospects for materials engineering? It's great, okay? But you have to check the data, and most of the time you can find this from US labor statistics. And you can see how much we get paid and is there any job prospect. And I already did those for most of our students, and briefly, and you can confirm what I say from US labor statistics. First of all, San Jose area in California is the #1 hirer for the materials engineering in the nation, okay? And in the area we have Stanford, Berkeley, and San Jose State, that, you know, at the core. And the number of materials engineering graduates are not enough to fill those jobs in the area. So you can definitely find a lot of jobs. And if you also check the details of these predictions in the US labor statistics, last time I checked, they included a couple % growth due to additive manufacturing. Because additive manufacturing, although it does a lot of stuff, it heavily depends on understanding materials and their internal structure. So what happens there? So if all the companies are switching to additive manufacturing for certain parts and products or new products, then they definitely need materials engineering. And from the innovation and science point of view, you know, it is really hard to beat materials science and engineering. The reason is, you know, we interact with, as you have seen, Mina going down to, you know, subatomic level, and earthquake prediction to Anthony's NASA work on thermal protection tiles of the space shuttles NASA uses, right? So I would say it is actually better. And also from a competition point of view, you will be in a very, very good place because, you know, you're not, you know, mechanical engineering or, you know, other engineers or computer software engineers. There is a lot of those guys, right? Whereas for your case, you're much more specialized and fewer. So I think the job market is there. It won't shrink down as bad as some of the others. And you will also have the flexibility because of the materials curriculum, flexibility to maybe a master's in mechanical engineering. Generally, we get the opposite. People do mechanical, civil, biomedical. They finish their degrees and they came back to us to do their master's degree in materials because they realize how important the materials for their jobs. Okay, so you can do the opposite too. You know, honestly, it is also about you, right? If you're really active, outgoing, presentable, talking nicely, and those are some of the main skills that might actually affect your job prospects more than 50%. So people might not really look at what's your degree, but are you capable of doing something useful, manage projects in a timely manner, and we also try to, you know, push for those skills. And let me know if I answered your question or if you need more. Thank you. Mina, we can't hear you.
Sorry, I said, I guess we can also talk about senior design if no one's asking a question.
Yeah, you guys can talk about the senior design. Senior design is a 1-year, 2-semester course where the students actually work on different projects as a team or with industry too. So we have direct industry projects that we work on, work through the senior design projects. And through those projects, students also get their jobs sometimes, okay? For example, Jabil is a third largest third-party manufacturer in the world. And we have about 30 senior design students from the College of Engineering, work on 10 different projects generally each year. And you know, some of the good students are taken by the company, some others switch to other companies. But the whole project in the first semester and second semester, it involves a lot of skills that that might hard to get it from the other courses. And Mina and Anthony can talk more about their experiences.
Yeah, so the senior project, the senior capstone project is that's where you really get to showcase what all you've learned throughout your college career. But you go through 1 month of, okay, how would you want to design an experiment, how you look at time management, but also resources that you're going to be using, and you try to take out as many kinks out of that planning process as you can. And then the next phase is where you implement, you conduct the research, and you try to generate data that you can interpret. As far as Professor mentioned, with you can pair with companies, and that will count as an internship / work experience. So again, the destination of San Jose State is it's prime if you're looking for opportunity. At the same time, it won't be handed to you. You need to work for it. You need to read. But if you have the investment in yourself to pursue those avenues, sky's the limit in terms of learning and where you want to go.
Yeah, and I guess specifically for senior design, we have a year to do a project, and the nice thing about materials engineering is you pretty much have the freedom to do pretty much anything you want as long as it's within the major. And you know, advantage of that over, like, for example, chemical engineering, they're given they have a real life client and they're paired up with 3 other people, so like you don't get to choose them, and you just do your project for that client, and it's not really physical. But for materials engineering, the nice thing is you can do actual like experiments and get hands-on lab experience if you didn't get to do research during your other years. And a lot of students do their actual research project as their senior design. And a lot of people start a little bit ahead of time, junior year, deciding what they want to do. So yeah, it's really nice.
And then to add on to Mina, for how you determine your senior project, there is no list that says, okay, one group does this. You really have the freedom to choose and pick a direction of how you want to proceed with your project. For my project, I'm doing additive manufacturing of porous ceramics. That could be used either for filters, but it encompassed two aspects that I liked, which was 3D printing and ceramics. So that is the freedom as a material engineer. You basically pick a material or pick a process, and you can look into that. So there is freedom when it comes down to senior design. It's not okay, you have to do this project just because it's on a, you have to pick from this list. So in that terms, I'm grateful that it offered that flexibility to pursue my individual interest into something. That's as far as I can speak to in terms of a senior design project. So it's a good opportunity. Also during that curriculum, you get to feel like an engineer just before you're out into the engineering world. And I mean that by we do have presentation opportunities where we present to actual industry or people that were in industry, and they can kind of they can constructively give criticism on, hey, oh, that's, or give good feedback on, oh, that's an interesting idea. But it allows you to help your presentation skills and delivery of a project. And we have another question. Let's see.
All right. So question is, how many students usually enroll for materials engineering instead of other fields of engineering? Materials engineering, I would say, one of the smallest departments. So that is actually a good benefit, and maybe not more than 20, 25 per year. All right. So total of undergrads is about 100 students for our department. And if you check like mechanical, it's about 1,000 students. Software engineering, probably 1,500, more than that. Biomedical is around 500, I guess. So they are actually quite different, okay? And the small size and a lot of lab space, actually, we do have a lot of lab space. And I also started this new advanced manufacturing lab. College of Engineering started it actually with some other faculty. So we do get access to almost everything as a small group. But I would say we are also pretty active in terms of research. That might be the reason to perform a lot of research and also raise grant money and work on some of the state-of-the-art teaching tools such as the virtual reality. So I am able to test those on students. I did it actually before. And we are trying to put them into regular classes too. That means we are benefiting the small size of the department significantly. And knowing that the area is the #1 hire for the materials engineering, I assume it's actually a very good deal. Let me know if I can answer it in more detail to you. Thanks for the question.
If you let me, well, I want to add a little something to that. For those that are either just graduating high school, how many of you knew about material engineering versus computer engineering, electrical engineering, mechanical engineering? I mean, those are the big ones. For me, I was actually in EE before I switched to materials. And partly was because I didn't know what materials was, but I kind of like looking at a materials aspect of, oh, you can, if you change the structure or if you can change the properties of that. So before you think, oh, material engineering is a small department, why would I want to go to that? I would either do a little more research on what material engineering is, but also understand that Oh yeah, yeah. What is material engineering? If you're looking into something like college, I was exposed to material engineering during my freshman year, where we had to take an introductory to engineering class, and actually, Dr. Kellis spoke at not a symposium, but one of the class periods, and that really piqued my interest in. Okay, let me look at material engineering, but also. That's where I joined some of the material engineering clubs. Again, I hadn't fully switched over to that point, but it was something that interested me. Um, but just by going to that club and talking to some people, it brought me to the light side or the dark side, however you interpret that. So
Light
again,
side.
yeah, it's material engineering. Yeah, the light side, of course.
I guess also to add a little bit to that, because the materials engineering department is so small, everyone in your class is your friend, and I feel like, in electrical, you have like thousands of classmates. You'll almost have more friends if you're in a smaller department because you just interact with everyone more time, and you just like it's just a better community. It's very friendly and everyone is kind. And another advantage is having more exposure with your professors. It's much easier to ask for a recommendation letter because all your professors know you, and they just like Dr. England, who's our crystallography professor. I've taken his class 2 years ago. He sees me, he's like, hey, Mina, but like how many electrical engineering professors can do that with their students? I don't think that many.
Yeah, I would say, for the money you pay, you're actually getting quite a bit of deal, from San Jose State. Also, materials engineering, I guess, one of the best value departments. And I have one more question or two more questions. How would one start looking for internships at SJSU? There is actually a career department that you can go and talk to people, and they will direct you towards the opportunities. College of Engineering also generally has some other information that you can click and find. Our email list is also every month we have, at least 3-4 emails related to calls for the internships. Not only the ones that we directly send to students from the faculty, but also if it is like we don't have a suitable student, we actually put the opportunity to the whole department and anyone can apply. But I guess, just web and, finding the companies, talking to them, going to the network events are the key to find a successful internship. And if you're in the MA or SP, Material Advantage or Society of Plastic Engineers student club, it's almost impossible to miss any internship opportunity. They will put you directly in front of your face. And
yeah, and then if I can add a little bit more to that of how looking for internship. Also, it's looking for, you realize that a lot of power that comes with just not knowing people, but talking to people, but just being classmates with people. And as Mina said, you do build a kind of camaraderie with students in your field. And some of those students will graduate and they'll go into a course, and then their manager will say, hey, do you know anyone? And they'll remember, hey, oh, I remember that guy or whatever. So there's an opportunity to grow that, that relationship with either professors or with other students. But as Professor Kell said, the clubs, the research professors, but also the department, they do send out, people, either companies that are looking for people.
All right, Anthony.
There's another
Let
question.
me ask this last question too.
Oh, you.
How can students double major with materials and chemical? Do we recommend it? What I would suggest is, get into the materials engineering first, as I would say. And if you ace the classes, right? If you are above a certain GPA that you set a goal by yourself, then you can start to maybe take some of the core chemical engineering classes or chemistry classes, whichever major you want to do, and then see how the load is increasing. So I wouldn't really jump on it and then, get bad grades overall. I would do a couple more classes, maybe as a minor, actually, right? If you get passed through the core classes, then you can say, hey, I'm acing this, I will switch to double major, and then just kill it like that. So, and there is no problem. You know, you go to the advisor, you say, I want to do this. If both departments agree, you basically start doing your double major.
I guess sorry, I would just say, like, I'm not sure if there's like a point necessarily in majoring in both materials and chemical, because you can definitely, like, because they're both very universal types of engineering, so it's better to do like materials and like software or computer, but I'm not sure why someone would do like both material and chemical.
You guys can decide if you come here. I guess this was the last minute. I would like to thank everyone who prepared this panel, joined this panel, and came to listen to us and ask questions. If you have other questions, you can find my email online and shoot me an email. Anthony and Mina can also put their emails in the chat box, and I'm actually writing right now mine. If you email us, we'll try to return back to you as soon as possible.
All right, thank you so much, everyone. Let me go ahead and put this up here. Okay, so thank you everyone for attending. If you have any further questions, please also email them to engineering@sjsu.edu. At this time, I would like to invite you all to exit this meeting and visit other sessions that may be of interest to you. And thank you again for your time. Congratulations on being accepted as a Spartan. We look forward to seeing you in the fall. And thank you so much, Professor Anthony and Mina. I hope you guys stay safe and have a great weekend.
Thank you, Jesse. Thank you, guys. Bye-bye.
Bye.